that are much further away than our sun. And this is why we should really take advantage of how close the sun is to Earth. And this is why we should try to monitor it, to observe it, and to try to understand as much aspects as we can from the sun. And again, as I told you earlier, everything we're gonna learn about the sun today can be later on applied to other stars. This is why it's very important to understand our own star, which is the sun. I'm gonna be a bit brief here, just that you know. Briefly, the sun, right there, it is the largest object in our solar system. In fact, the sun has more than 98% of the mass, or 99% of the mass in the solar system. So to um, if you would to weigh all of the planets together, they wouldn't make up 1% of the weight of the sun. So obviously the sun is the largest, it is the most massive object in our solar system, and this is why all of the planets are orbiting around the sun, because it has the highest mass and thus it has the highest gravity. The sun is also a black body radiation. Don't worry about don't worry about this graph, but what I wanted to tell you is that the sun is a black body, which means that it emits light in all different colors. If you remember, we usually talk about the color of the sun, and I usually say that the color of the sun is white. The reason why it's white, it is because it's a black body, meaning that the sun gives light in all different colors, and when you combine all different colors, then you get the white color. So for example, the sun gives red color, it gives yellow, it gives green, blue, violet. It also gives lots of the invisible colors that you can see, ultraviolet and infrared and so on. And so if you combine all of these colors together, you get a white color, which is why our sun is white. Now, let's go into more details now when it comes to the sun. This is a new term that I want you to learn. It's called the luminosity. And when you want to talk about stars, really, and our sun, you want to talk about how bright they are. And the brightness is reflected by what we call luminosity. So the luminosity is also the brightness in some way, and the definition of it is the total amount of energy emitted by the sun per second. So the sun gives so much photons, so much energy per second. If we count these and we divide them by 1 second, we get what we call the luminosity. So the brighter the star or the brighter the sun, the more luminosity it will have. This is very similar to the projectors we use in classrooms. The brighter the projector, the more luminous it is, the more energy it will give, the more light it will give. Luminosity is nothing but the total amount of energy emitted by the sun each second. All right? So it's like the brightness, it's the same meaning, really. And this is the number, which of course you don't have to worry about, but the sun gives a lot of joules in every single second. And so it gives 3.9 times 10 to the power 26 joules in every single second. If we would to store this amount of energy which the sun emits in every second, then we would have enough energy to use here on Earth for years. Also, I want to introduce something new other than the luminosity, and this new term is called uh, energy, really, or flux. It's the same meaning. So energy here, this is a formula you need to know. Okay, energy, which is F, which is flux, which is energy, is equal to a constant times T to the power 4. Okay, T is the temperature. Um, if you recall, when we look at equations, all what we care about really would be the variables and not the constants. So this is a constant, so forget about it. So what this equation is telling me is that the energy that comes out of the sun is proportional to the temperature of the sun to the power 4. شو يعني؟ يعني if you increase the temperature by a bit, if you increase the temperature by a bit, the flux, يعني the energy will be increased greatly. So the temperature and the energy are proportional to each other. The hotter the star, the more energy it's gonna give us. The cooler the star, the less energy it will give us. And it is very sensitive, and no, it is T to the power 4. So if you increase the temperature of a star by only 10 degrees, then the energy will be increased by 10,000 times. Can you imagine? Big number, because this relationship is proportional to T to the power 4. So increase the temperature, flux will increase greatly. Decrease the temperature, the flux will decrease greatly. So they are proportional to each other. هذه هي الفكرة. So حكينا عن luminosity وحكينا عن energy. This is the equation we use to get the energy coming from our sun or from stars. Now كيف الستارز بيعملوا energy؟ stars, they are shining, they are giving this energy, they are giving light because they are fusing hydrogen to helium at their cores. So if you go to the core of our sun, هتلاقوا إنه the temperature there is crazy, the pressure is crazy, the conditions are exceptional, and this is why fusion can happen. شو يعني fusion? Fusion يعني when you have hydrogen atoms fuse together to form a new element, which is helium in this case, and energy. شو يعني هالenergy؟ يعني الضوء، يعني the light, the photons, the gamma rays, the X-rays, the light you see when you look at the sun, the rays we get from the sun during daytime. هاي الenergy اللي عم نحكي عليها. Okay, so this is how stars shine, because they do fusion by this equation, and this is something we have already talked about in the first unit. So hydrogen fusion also takes place in all of the stars visible to the naked eye. كل star بتشوفوه عم ضوي, it is because at its core, at its center, hydrogen is being fused to helium. And one thing I want to tell you is that stars usually have two competing forces. Okay, the first force is the force of gravity. The second force is the force of pressure. يعني because the star, our sun, يعني, is so large and is so massive, the mass of the sun is trying to crush the star to the center. But as the gravity crushes the star to the center, you have an opposite force which acts opposite to the force of gravity. And that opposite force will be the force of pressure. Yani, gravity, it tries to crush the sun, and oppositely, pressure, it does a force which tries to expand the sun. If gravity wins, the sun will contract وبتسكر على حالها. If pressure wins, then the star will expand, the gases will be thrown away, تتحول لنبula. If gravity equals to pressure, you have an equilibrium, which is the case of our sun. Our sun has an equilibrium. You don't see it getting larger and smaller every day, right? So it is an equilibrium. شو يعني؟ يعني the forces of gravity are equal to the forces of the pressure. Okay. So, more about this. Another thing I want to tell you is, at the core of the sun, which you can see here, اتفقنا إنه هون, I have fusion. This is where hydrogen gets fused to helium, and also to light, and to some other material. One of these byproducts of this equation that happens at the core, and one of the particles that are born when fusion occurs, لما يصير في عندنا equation of fusion, شيء اسمه neutrino, and neutrinos are very small and tiny particles that can penetrate through the sun really fast. So okay, I don't want to confuse you, so I'm gonna just let me see what we have here. Okay, so let me go back. Let me go back and explain this. لما بيصير في fusion هون, okay, forget about neutrinos for now. لما بيصير في fusion هون على الديكور شايفين, you get photons, you get light. So the light will try to come up all the way to the surface, right? But because the density of our sun is so high, then the photon will struggle really while it is going upwards. So it's gonna take it hundred thousands of years for one photon to move from the core all the way to the surface. And then it will take 8 minutes from the surface all the way to Earth. So تصوروا إنه الفوتون الضوء it takes around 100 to 200,000 years to move from the core of the sun to the surface of the sun. Again, it is because there's a lot of pressure and density here in this region. A neutrino, which is also born by the fusion reaction مثل الlight, it can move really fast from this point all the way to the surface of the sun in 1 or 2 seconds. Why can it move so fast? Because it is so tiny, because it is so small. So even when it comes to Earth, it can penetrate through the Earth, and it can penetrate through Earth from one side to another in no time. And every single second, really, you have 100 trillion neutrinos passing through your bodies. Now, of course, I can talk for hours with you about neutrinos, but I think this would be it for now. Okay? بس لأرجع, I just want to make sure you know what I'm talking about. Okay? See this equation? Hydrogen atoms are fused to form helium. هذا بيعلق بالsun at the core. Plus energy. What is this energy? The light يلي بيضلوا 100,000 years to get to the surface, and neutrinos. Okay, so neutrinos are one of the byproducts of this equation. مسبب إنه neutrinos are so tiny, very small, they do not interact, they can penetrate through the sun in a very short time, they can penetrate through the earth, they don't interact with anything. Okay? So this is what I wanted to tell you about neutrinos and the sun. So next, I want to tell you about the different parts that makes up our sun. And let's dissect the sun. The sun is made from 3 main parts, something called the photosphere, the chromosphere, and the corona. Okay, and if you want to see a sketch of the sun, هيك شي. This is the core. The core is the hottest object of our sun. It is at the center of our sun. It has a temperature of 15 million degrees. At the core is where fusion takes place. At the core is where light is born. Okay, everything happens at the core. Now, as you move further away, إذا أنا بمشي من هون بوصل لهون, obviously the temperature will drop. ليه؟ لأنه I am now further away from the core. The core is the nuclear reactor of the sun, so it has to be the hottest object. يعني مثلا on Earth, the hottest part of Earth is at its core. هونيك في all of the lava at very high temperatures. نفس الشيء with the core of the sun. The core of the sun is very hot, has a temperature of 15 million degrees. This is a crazy number. Okay, هذا كتير رقم عالي. But anyway, as you move away from the core, the temperature drops, it drops, and then you get to the surface of the sun, which is what we call the photosphere. This is the photosphere. The temperature of the photosphere is 6,000 degrees. Look how different it is now. At the core, it was 15 million. At the photosphere, it is 6,000. ليه؟ لأنه as you move up, the temperature will drop. Now, at the chromosphere, which is a layer above the photosphere, the temperature increases. بيصير 27,000 degrees. And at the corona, which is the outermost layer, it is 1.7 million degrees. I know this might be confusing, so I want you to forget about chromosphere and corona for now. Okay? Let's just think of the core, 50 million degrees. You go from the core all the way to the surface, the temperature will drop. آخر شيء بتوصل 6000 degrees at the photosphere. انسوا chromosphere و corona. When you look at the sun, إذا بتطلعوا and you just look at the sun, you don't look at the core, you don't look at the corona, you don't look at the chromosphere, you only look at the photosphere. So all people on earth لما يطلعوا على الشمس, they only see this part, the photosphere, the 6000 degrees. يعني تصوروا قديش الهيت اللي بيجينا من الشمس and how hot it can be on earth because of the sun, and yet we are only looking at the photosphere. Imagine if the temperature of the photosphere was 15 million degrees مثل الكور. If this was the case, أكيد there wouldn't be life لأنه the planet would have evaporated. Earth cannot really stand being in front of a sun which has a temperature on its surface of 15 million degrees بتتبخر. So luckily, we only see this little part, which is what we call the photosphere. I'm going to tell you about chromosphere and corona. Why can't we see them and why are they so hot? But I wanted to explain more about the photosphere أول شيء. And so I'm just reading now. We can see about 400 kilometers into the photosphere. ذكروا الشمس كتير كبيرة. All right. So the radius of the sun is 700,000 kilometers. And a diameter 1.4 million kilometers. If I'm not mistaken, the radius of Earth is 8,000 and the diameter is around 8,000 kilometers. At the Earth. The radius of the Sun is 700,000 kilometers. It's crazy, crazy big, really. And remember, you can fit more than 1 million Earths inside the Sun. So, just for you to understand how big the Sun is. And I don't have to go over this again, بس نحن متفقين إنه the photosphere, just like the sun, is mainly made from hydrogen and helium. Of course, we know this. The sun mostly is made from hydrogen and helium. Now, what is the sun made from? Hydrogen and helium. But if you point your telescope at the surface of the sun, what do you see? You see a surface which looks like this. مع إنه the photosphere مثل the sun is made from hydrogen and helium, but remember it is at very high temperatures. So if you want to really think about the sun كيف شكلها, it's gonna look like an ocean, but that ocean isn't really made from water like on Earth, but it is made from very high made from hydrogen and helium at very high temperatures. Think of volcanoes when they erupt, the lava, how they move on Earth. This is kind of how the sun looks, but at a very larger scale and at a very higher temperatures. So, إذا بتطلعوا هون, this is a real image of the sun, you see? This is the photosphere, ليكوا هاي الشقفة. This is all hydrogen, helium at very high temperatures. But this is not stable. مثل ما ocean isn't stable, you always have waves moving right and left. Kind of it is the same on the sun. So this will always be changing, but it is the same structure. So we call these granules. They measure around 1,000 kilometers, more or less. They are surrounded by darkish boundaries. I'll tell you more about this. And just to be more clear, لأنه هاي الصورة not very clear, this is more clear. This is a zoomed in real image of the sun. These are, you see, هيدي مثلا الشقفة. This is a granule. هيك بنعيط لها. This is another granule. This is another granule. This is another granule, and so on. I'm gonna play this video, and you can see how everything is moving, just like oceans, right? But it is made of very hot hydrogen and helium. So هو اسمهم granules. They are, random islands found at the surface of the sun, يعني at the photosphere. They come in different shapes. They can be small, not really small. They can be large or super large. Some of them are 5 or 10 times larger than Earth. إذا بطلعوا هون ليكوا size of Earth compared to these granules. Okay? I just want to answer one question if you are wondering. طلعوا كيف, let's take this as an example, this one. Okay, so it is very bright, this granule, but look at the boundaries. Kind of dark, right? Well, they are dark لأنه the temperature here at the boundary is less than the temperature here. Okay, and this has to do with something called convection. This is the way of how can the sun maintain its temperature. I don't want to talk much about convection right now, but I just wanted to mention it. انسوا هيدا because بعد ما حكيت عن what is this, I haven't spoken about this, I haven't explained this. I'm just talking about these here, granules. Okay, now if the granule مثلا look كأنه ocean really. If the granule was very big, we call it super granule. And remember, kill granule, like granules, they don't live forever. Like you can have a granule for 5 minutes and then it disappears and then a new granule will be formed. You can have granules living for a longer time. Okay, and it's like a wave. You can't بالاocean. You can't say, well, this wave will last 10 years. No, this wave randomly will appear and then it will disappear وبيخلق محلها another wave and so on. Okay, so this what اللي عم نحكي لهلا كل هول we have talked about the photosphere. Okay, كله هذا photosphere. هون الconvection if you wanna learn more about convection. Okay, see this is a granule and this is the boundary حوالين الgranule. It's dark. Okay, anyway, this is what I wanted to tell you about photosphere. The second outermost layer هو الchromosphere, which is a layer above the photosphere. The chromosphere weirdly has a temperature of 27,000 degrees. غريب ليش؟ لأنه it is far away from the core. Why would it have a temperature which is even more than a photosphere, which is closer to the core? Kind of weird. بس هلا I'll tell you why at the end. Okay, but the second outermost layer of the sun فوق الphotosphere هي chromosphere. مع إنه chromosphere is above the photosphere, we cannot see it. When you look at the sun, you only see the photosphere and not the chromosphere. But this is where you can see the chromosphere. When you have an eclipse, look, this is the chromosphere right there. ليه ما بنشوفه؟ لأنه it has a low density. Okay, يعني انتوا بس تطلعوا when you look at clouds, sometimes you see them clearly and sometimes you don't see any clouds مع انه بيكون في clouds. ليه ما بتشوفون sometimes? Because their density will be low. You know what I mean? And it's the same thing with the chromosphere. The chromosphere is a layer above the photosphere, but the density is low. يعني ما في كتير atoms, ما في كتير molecules. And thus, it is kind of invisible. But it is possible to see them when you have an eclipse. ليه؟ لأنه this is when you block the very bright photosphere, so you'll be able to see the chromosphere. Okay? بعد ما قلت أنا ليش temperature عالي تبعها, بس I just said why we cannot see it. Now the outermost layer, the third outermost layer of the sun is the corona. It is hot, thin gas, high temperature. Look, 1.7 million degrees. كمان غريب, كمان غريب. I mean, we always expected it to have less temperature. Okay? And it has highly ionized iron atoms. على فكرة نفس الشيء with the corona. Why is it so hot? Or why can't we see it? لأنه it has low density مثل الchromosphere. Okay, how can we see it? Again with an eclipse. It's a randomly shaped part of the sun, and you know, this is where you can see it. This is the corona right there, whole radiation. هلا إذا شلت أنا هيدي الeclipse, if I remove this dark disk from the sun, then the light from the photosphere will overtake the light from the corona. مش هيك ببطل فينا نشوفها. You know? But when I block the light coming from the photosphere, I will be able to see the corona. I hope it's clear. مثلا Einstein, he used, well, I don't know if I want to use the Einstein example. لأنه he used an eclipse to actually to prove his theory of relativity, and it's kind of related to this. بس اللي بدي لكم إياه إنه people back in the time used to wait for eclipses to see the corona and the chromosphere. أما اليوم we have methods to better look at them and to see them better. بس this is a proof. شفتوا هولي إذا بتطلعوا هلا على الشمس you don't see these. إذا صار eclipse وطلعتوا على الشمس بتشوفوهم. So this is the proof that they are actually there. Okay? Again بعد ما حكيت why they have so high temperatures, but I will get there. Now I think بعد في عندي 2 or 3 parts that I want to discuss. أول شيء هي sunspots, and I'm just gonna take you directly لشيء قلته قبل. Yes, right there. See هيدا الفوتوسفير، هول الجرانيولز اللي حكينا عنهم على الفوتوسفير. And look at this region. This is a big region at the surface of the photosphere. Perhaps it is larger than planet Earth. It is so weird لأنه the sun is very hot. The sun has a nuclear reactor at its core. The photosphere has a temperature of 6,000 degrees, which is really high. Alright? Why do we see something dark at the surface of the sun? It's kind of weird. These are what we call sunspots. And sunspots أول شيء كنا نفكر إنه weird, but now we understand them better. Not fully, but we understand them شوي. But sunspots like this one here are areas that are found at the surface of the photosphere, يعني at the surface of the sun, and because they have less temperatures than their surroundings, they appear to be darker than the surroundings. يعني هيدي الاريا at the surface of the photosphere عندها temperature أقل من 6,000 degrees. And this is why when you have something which has temperature, let's say, of 4,000 degrees وبتحطوها حد شيء عنده temperature of 6,000 degrees, هاي الشقفة بتبين it is darker. It's not really dark, it's not really cool, it is just darker and colder and cooler than the surrounding. Okay? So sunspots, you can read a bit about sunspots, but this is what sunspots, this is why we see sunspots. هلا I'm gonna tell you even more about sunspots, which will explain why the corona and the chromosphere have higher temperatures. Okay? But give me a few minutes until we get there. Okay? يعني الشمس حتى هلا if you take a telescope تحطوه على الشمس, most probably you're gonna find dark areas at the surface of the sun, which will reflect that these are sunspots. Now, solar flares are explosions that happen at the surface of the sun, على الفوتوسفير كمان. And this is an example of a solar flare, يعني مثل solar wind, انفجار. Alright? And when this happens, when something at the surface of the sun explodes, then you're gonna have a lot of ejected material from the surface of the sun. When this happens, you see all of these materials are escaping from the surface of the sun because of that explosion. And if they escape, is an earth hone, whoop, maybe they're gonna come towards the earth. And these are really dangerous. So coronal mass ejection are large amount of high temperature coronal gas is ejected into space. أحسن شيء فرجيكم فيديو. So look. Whoop. See? Sometimes when you look at the sun, whoop, you're gonna see an explosion like this one. هتتعرفوا Earth is, the explosion is larger than Earth. So Earth is really a tiny, small part if you want to place it in front of this explosion. So this is very dangerous. Actually, you can see Earth here. Look, هشيل الماوس, then you are able to see it. You see? Earth تحت على اليمين is really small compared to that explosion. So إذا هذا الشيء صار in front of Earth, then we are in a problem, big problem. See قديش بيطلع material. Are you watching? Very dangerous. So these are what you call solar flares, and these are what causes auroras, or what you call northern lights on Earth. I'll show you all about this. Excuse me, بس عم يعلق شوي عندي. Okay, so look, in this video, I'm gonna play it, I'm gonna explain it, and if you really understand it, then everything should be fine for this chapter. And just for me to remind you, إنه قلت لكم إنه solar flares, they cause the auroras or the northern lights. I'm gonna explain it in the video. This is why I skipped these two slides. بس let me tell you قبل هيك سريعا, and then I go back to the video and then I re-explain it. If this is the sun, explosion takes place, what we call solar flares, okay? And when this happens, a large amount of material will be ejected from the surface of the sun, and this material will move all the way to Earth. مش دايما, sometimes. Now, if all of this material comes to Earth, we're gonna have serious problems on Earth. But there's one thing that protects our planet, and that thing is what we call the magnetic field. So, but بيجي هول material, they see this magnetic field, and this magnetic field will diverge them into different places, and thus it will protect our planet. حتى تعرفوا إنه this storm here is also caused by the sunspots. يعني هون بيكون في sunspot محل ما بلشت explosion, وهون بيكون في sunspot. If they connect, بيصير في عندي explosion. Okay, I'm gonna explain this بهالفيديو. So أول شيء, this is the sun. When you look at it, you are seeing the photosphere. Yeah, you see the granules. Everything is so hot at 6,000 degrees. هون الكورونا والchromosphere. هون برا. You see? Now, let's go deep into the core of our sun. So if we go to the core, what do we see? We see a volume which has crazy temperature of millions of degrees, crazy amount of pressure, crazy conditions. When you have these conditions, شو بيصير؟ بيصير في عندي nuclear fusion. شو يعني nuclear fusion? It is when hydrogen atoms are fused together, they are merged together to give me a helium atom. And not only helium atom is, see here, hydrogen fused to give me helium and light and energy. Some of this energy we receive from Earth. Some of it gets stuck for a long time at the core of the sun. See, so لما خلق الانرجي والضوء هون, it's trying to come all the way up to the surface. Oh, sorry guys, sorry. Actually, let me play this.
The light radiates outward from the core of the sun. In the outer layers, the heat moves to the surface in huge eddies called convection cells. These electrical currents of charged gas create magnetic fields inside the sun. In some places, strong magnetic fields push their way up through the surface. They slow down the eddies of hot gas. The surface cools, and darker sunspots appear. The electrically charged gas is called plasma. The plasma drags the magnetic field further outward.
Okay, بس بدي أكد على اللي قاله إنه he's saying that the energy is created at the core مثل ما حكينا بالfusion, and then it tries to go all the way up to the surface, okay? And sometimes you have you form what we call dark spots, okay? And sometimes you form these dark spots, which what we call sunspots. Now, if the two sunspots, the magnetic field lines of the two sunspots combine together, this is when you get a solar flare. If you get a solar flare, you eject so many materials to the solar system. If this material comes to Earth, the magnetic field will protect us, and we're gonna see auroras. Okay? I'm gonna play this.
Surface. They slow down the eddies of hot gas. The surface cools, and darker sunspots appear. The electrically charged gas is called plasma. The plasma drags the magnetic field further outwards. The magnetic field stretches and twists like a rubber band, and then the rubber band breaks. Several billion tons of plasma is hurled out from the sun. This is called a solar storm. The solar storm can reach speeds over 8 million kilometers an hour. After 6 hours, it blows past the planet Mercury.
So it's just showing you, and when the storm happens, the material is ejected into the solar system, and this can cause harm to, to life on Earth. But luckily, الاتموسفير تبع الأرث sorry مش الاتموسفير the magnetic field of Earth will protect us from this, and now we can see.
The solar storm reaches Earth. When the solar storm reaches our planet, something strange happens. An invisible shield, the Earth's magnetic field, deflects the storm. The magnetic fields couple together and create a funnel where the gas streams down on the daylight side of the pole. This is the daylight aurora. The magnetic fields stretch further back and couple together. The magnetic rubber band breaks, and gas from the solar storm streams along the magnetic lines towards the poles on the night side. This is the nighttime aurora.
Yeah, so this is all I wanted to say about this chapter. So I suggest you go over this lecture, maybe divide it into two parts, small أول part, and then try to understand everything, and then go to this second part where we talked about the different parts of the sun. Yeah, so this is all for now, and I would like to thank you for listening.